Hello students, how are you? Once again we meet in our micro teaching part 3. Okay, this is a continuation of what I've discussed in the last class. So I hope you all can follow. Okay, today basically we are going to learn a very important concept called specific heat capacity. Specific heat capacity. This idea I touched a little bit in the last class when I was solving the question. Okay, this one given a symbol of C, small letter C. Okay, our today lesson mainly will be on page 63 and 64 if you refer the notes, and later we can try the questions at page 66. Okay, so I'll tell you what are the questions we can try later. Okay, before that we need to understand this concept of specific capacity. Remember I was telling you about copper pot and clay pot the other day. When you're heating it up, the copper pot becomes hot faster, the temperature rises faster compared to clay pot. Okay, basically, okay, if you refer at page 63, there's one more concept that talk about heat capacity. The word specific is not there, heat capacity. Okay, this concept I'm not going to touch because it's not in the syllabus. It's the same idea of heat capacity, specific capacity, but it's slightly different because we don't consider the mass, right? But for specific capacity, we have to consider the mass of the object which you are heating it up. Okay, so to start with, let us now just take an example. Right? Let's say I take, I'm going to now relate how this specific capacity relate with temperature, relate with heat, and also the mass of an object. Three things. Mass of an object, the heat that you supply, right? The heat that you supply. All these are symbols that we use in this concept. Right? And then temperature, right? Temperature, we use symbol theta. This is Q, this is Q, this is theta. Then specific capacity itself, specific heat capacity, heat capacity itself, alright, which we give a small letter C, small letter C. Okay, alright. So to start with, let us look at one a simple example. Let's take a block of metal. You block of metal, you heat it up. You try to measure the temperature. You put a hole here, then you try to measure the temperature of the metal block. Right? So you heat up. Right? Initially, let's say the temperature is theta 1. After some time, after heating it up, of course the metal block become hot. Okay, it become temperature theta 2. Right? The temperature become theta 2. Okay, this is inside, this thermometer is inside the metal block. Okay, alright. And of course, the amount of heat, let's say when you're heating it up, you can measure the heat. The heat that you supply is Q. Okay, and then the object got a mass M. Alright, when you're heating it up, and with the temperature from theta 1, it goes to theta 2. Of course, temperature is, when you heat it up, the temperature become higher. Alright, theta 2 more than theta 1. Okay, so let's say if I apply more heat, what will happen? If I apply more heat, the temperature theta 2 will become even higher, right? Become more, right? That means the temperature rise, right, of this object is proportional to the amount of heat that I supply. Okay, at the same time, I also can take mass. Okay, instead of using a small block, let's say now use a bigger block. Okay, let's say I use a bigger block and I heat it up with the same amount of heat. Okay, I heat it up with the same amount of heat, In your idea, okay, this is M. Let's say this is big M, bigger mass. So, do you think the temperature initially theta 1? Do you think this temperature, let's say theta 3? Is it going to be the same as theta 2? Definitely not. So from your idea, if the object is very big, let's say you take a big pot, you heat it up, you put a small pot, you heat it up. Same amount of heat is supplied. Definitely the pot which is much bigger is not going to get the same temperature. The temperature will be much lower. Okay? So therefore, the temperature, just now the temperature rise is proportional to the amount of heat that is applied. Okay, that means you also can write that more the heat, higher the temperature rise. But in this case, the same amount of heat you are supplying, right? The mass, if you are using more mass, okay, the temperature rise is going to be less. That means the temperature rise is inversely proportional to the mass. Okay, so here the temperature rise is directly proportional to the Q. Okay, let's say, alright. So here we have a relationship that with the temperature and thing, that means the temperature rise is directly proportional to the amount of heat that you are supplying. Okay, the amount of heat you are supplying, and the temperature rise also is inversely proportional to the mass. Okay, that means we can combine these two. These two is equal to, now is proportional to Q over M. Alright. So the temperature that we are heating it up is also influenced by the amount of heat, and the temperature rise is influenced by the amount of heat. The temperature also rise also is influenced by the M. Here the temperature rise, or you also can say temperature change. This theta is actually temperature change. What is the temperature change? Higher temperature minus lower temperature. Okay, we can write later, but that for the time being we just know that the temperature. This is actually temperature change. By that, it should be temperature change. Okay, how much temperature it rises. Okay, okay. So we already got this idea already. Okay, at the same time, now let's say this is two things. Okay, it's regarding one particular metal. Maybe let's say it's copper. Okay, instead of using copper, now I use, let's say, aluminium. If I use aluminium, I supply the same amount of heat. Do you think the temperature rise may be the same? Definitely not the same, right or not? Definitely not the same. It depends on the concept called that. This is where we will bring in the specific heat capacity concept. And the same aluminium, now I use a bigger aluminium, I heat it up. Definitely the temperature is rise, but it's not going to be same as copper. That means different metal, the temperature rise will be different. That means different material, it will have a different temperature rise. That means the temperature rise is depend on the material. Okay. This property of temperature rise, which is depending on the material, is known as the specific heat capacity. Alright, specific heat capacity. If the material, okay, if the material has a smaller specific heat capacity, so remember this. Okay, let's say now the material have a smaller specific heat capacity. That means it become hot faster. Copper can become hot faster. So the specific heat capacity of the material, okay, is inversely proportional to the temperature rise. Okay, temperature rise. Just now what we got? The temperature rise is proportional to the amount of heat. It is also proportional to the, inversely proportional to the mass. Okay, so now if I see here, I also can write the other way. The temperature rise is depend on the specific capacity. If the specific capacity, it need little bit of heat, the temperature go very fast. If there's a bigger specific capacity, the temperature rise will be smaller. Like for the case of aluminium, or you also can say copper and clay pot. Right? So clay pot, why the temperature is going up very slow? Because the specific capacity, that means you need to absorb a lot of heat in order to rise the temperature. So the specific capacity of the clay pot is more. It has to absorb more heat in order to raise the temperature. So combining these three, so we can say that the temperature rise is depend on the amount of heat that is supplied, and it also is inversely proportional to the mass and specific heat capacity. So now we go to the idea. Okay, what is the specific capacity? Specific capacity is directly proportional to the, okay, when you rewrite the equation, you can write this. You can say C is equal to, you bring it here, the theta will come here, Q over MC. So now we get this. So the specific capacity of the material is depend on the amount of heat it is absorbing, and at the same time it also depend on the mass and also the temperature rise. Okay, so put it very simple. So if you look at the unit here, this is amount of heat, this is mass, this is temperaturized. Okay, temperaturized we put theta. Okay, theta degree Celsius. So specific capacity, in other words, is the amount of heat required for the material to raise 1 kilogram of that substance by 1 degree Celsius. Okay, so this is the idea we are going to see today. So the definition of specific capacity is amount of heat required to raise 1 kilogram of substance by 1 degree Celsius. Okay, let's take a numerical example. Okay, numerical example. Okay, let's say specific heat capacity of copper. Let's say specific capacity copper. In your book, they already given you here. Okay, they give you for aluminium first. Okay, you take aluminium. Alright. So for aluminium, the specific capacity is given as 900 joule per kilogram per degree Celsius. Okay, what does it mean? It means if you take 1 kilogram of aluminium, okay, 1 kilogram of aluminium, you need to supply 900 joule of heat energy in order for the temperature of the aluminium to raise by 1 degree Celsius. Maybe let's say here is 30 degrees Celsius, it becomes 31 degrees Celsius. Okay, for this, you need to supply 900 joule for this 1 kilogram of aluminium. Okay, so if we say, let's say now in the book also they give you, the notes they give you water. Let's say you take water, 1 kilogram of water. Okay, specific capacity of water is given as 4200 joule per kilogram per degree Celsius. This is given. What does it mean? It means to raise 1 degree, let's say water is 30 degrees, now you heat it up, right, you heat it up, to become 1 degree Celsius, right, from 30 to become 31, the water need to absorb 4200 joule of heat energy. So this value, in other words, tell you which one can become hot faster. Okay, like aluminium you only need 900, you can raise 1 degree Celsius, whereas water you need 4200 joule of heat energy to raise 1 degree Celsius. So different material will have different specific heat capacity. So the specific capacity is defined as amount of heat. This one is, you can check in your notes. Amount of heat required to raise 1 kilogram substance by 1 degree Celsius. Alright. So if the substance has a higher specific capacity, that means it's going to raise the temperature very slow, because you need to absorb, water need to absorb 4200 joule, then only you can go by 1 degree Celsius, whereas aluminium 900 joule is enough already, you can raise 1 degree Celsius. Okay, so like water is almost like 3 times, plus minus about 3.5 times. 3.5 times is more than aluminium. That means you have to supply 3.5 times of amount of heat for the water to raise the same amount of temperature. Okay, here 1 degree you need 900. Here you need 4200 joule to raise the same 1 degree. Okay, so this is what you have to know. So first you have to know the definition. What is meant by specific capacity? So specific capacity, in other words, simply means amount of heat required for 1 kilogram of that substance to raise 1 degree Celsius. Okay, the unit is joule per kilogram per degree Celsius. Okay, the unit itself tells you 4200 joule of heat energy required for 1 kilogram of substance per kilogram per degree Celsius for 1 degree Celsius. Okay, so this is the unit. So from the unit and from the value we can tell how fast the object can become faster. So just remember, if the specific capacity is very high, the object will raise the temperature very slow. That means the object become hot very slowly. If the specific capacity is very low, the object can raise the temperature very fast. So usually metals, they have a low specific capacity, and insulators like wood, water, okay, oil, all these substances will have plastic, okay, they all have very high specific capacity. So when you heat it up, the temperature rises slowly. So this is the formula you have to remember. So if you rewrite the formula, right, what we get, so the amount of heat required for the substance is Q is equal to mc theta. So finally we get the heat, amount of heat supplied you need, right? The substance got a C specific capacity for m mass of kilogram. You need to raise the temperature theta, you have to multiply all in order to get the amount of heat that object required to raise that temperature. Okay, let's take example. Mass of an aluminium, again, let's say 390 joule per kilogram per degree Celsius. Okay, this is the specific capacity of aluminium. Let's say it has kilogram, 2 kilogram of mass. Alright, and you want to heat it up from 30 degrees Celsius to 40 degrees Celsius. Okay, initial temperature 30, final temperature is 40. So remember, the theta here is temperature change. That means final temperature minus initial temperature. Okay, this is a temperature change. So in this formula, the theta is temperature change. Remember that. It's not just a temperature. Alright, here I put temperature, then I say temperature change. Okay, so how much heat you need? So simply you write Q is equal to mc theta. So 2 kilogram of aluminium, specific capacity is 3390. The temperature change is 10. 40 minus 30. Okay. So 2 times 39 is 68. 0, then it's another 0. Okay. So you need to supply 6,800 joule of heat energy for the aluminium to raise its temperature from 30 degrees to 40 degrees. Alright, so you need to supply that much of heat energy. So if we check the unit, so you can see 2 kilogram, specific capacity 390 joule per kilogram per degree Celsius. Okay, per degree Celsius times by 10 degrees Celsius. So you can see that it's Celsius and the mass gone, so it just left with amount of heat. And this is another way of checking the units. So finally we get this value. So this is how you calculate. So they can give you, so here put it in mathematical analysis for the solution of these problems. We have 4 quantities: amount of heat supplied, mass of the substance, specific heat capacity, and temperature change. Okay, in exam usually they like to ask what is mean by specific heat capacity of a substance 300 like of water. What is mean by specific capacity of water 4200 joule per kilogram per degree Celsius? What does it mean by? So you just have to say, to raise 1 kilogram of water for a temperature of 1 degree Celsius, we need to supply 4200 joule of heat energy. Okay, this is for heating it up. Let's say you let the water to cool down. Alright, so for heating up, the water will absorb the heat. If the water cools down, the same amount of heat will be released. Okay, that means from like aluminium to from 40, he wants to come back to 30, it will release so much of energy. So specific heat capacity not is only used for heating up, it also for cooling down. For heating up means we give the heat, raise the temperature. If we leave it cool down, it drops the temperature. So when the temperature is dropped, so the temperature, the heat will be released. So you can use the same formula whether for heating process or cooling process for the change of temperature. Okay, there are some experiments also involved in this. Okay, how to determine the specific capacity. Alright, so maybe that part I will discuss in the next class. And an experiment, how to determine specific capacity. If we know this idea, to determine specific capacity, we must know how much heat is supplied, what is the mass of the substance, what is the temperature change. If we know these 3 things, we can find specific capacity for any substance. Okay, so this is a very simple example. So please review back my explanation again. Alright, on the idea of heat supply, specific capacity, mass and temperature change. Okay, you can read back the notes. And now we can try the questions at page 16.6. Okay, so for the next class I will discuss some of these questions. So before that I want you to try this question. You can try example 1 at page 66. Okay, and yeah. Okay, so only one question from here, okay, because other questions also involving the same idea, but they are talking about electrical energy and also, you mix two substances, you take 50 degrees Celsius of water, you mix with 20 degrees Celsius of water, okay, what is the final temperature is going to be when you reach, when they reach thermal equilibrium. All these are using the same formula, but the application, the involvement of idea is slightly different. I'll discuss more example with that. So for today, I want you to try the first question. I also will post some of the extra questions to apply these equations for you to try, get familiar with the formula and the idea. Alright, so very direct questions I'll post after this. Please try the first question. I'll give you some other questions in your Google Drive. I'll post it in your Telegram also. So you can try those questions in another day or two. We will discuss this question plus those questions. Okay. So with that I conclude. There are a lot of other things involving specific capacity and the daily life application, all that. We will come to that much later. But the most important is the understanding of the idea. Alright. How to what does this specific heat capacity means? Okay, the value. What does the value tells you? And it also give you an idea how fast the object become hot or cold. Okay, so I think with that I stop for today's lesson. So please try the questions and till we meet with the solutions. All the best and good luck to you. Have a nice day.